Alright, so the study that I conducted was the effects of water depth on sunlight intensity at Clinton Lake, right here next to Lawrence, Kansas. Um, and obviously, that's me from the University of Kansas. So, just a little background here on this study. Water molecules and suspended materials in the water affect light intensity in a few ways. Mainly they just scatter or absorb the light rays that enter the water. And I kind of had a hypothesis that, as you increased the depth that you measured the light intensity, there would be a decrease in the in the intensity, meaning there's a greater attenuation of light. I kind of thought this because greater depth should equate to more water molecules that the light has to pass by, and other molecules that are just in the water. So the objective of this study was to measure the light intensity values at different depths underwater at Clinton Lake. So how I went about doing this, I'm talking about this little measurement tool up here on the top right corner. That is kind of a combination of a light to frequency converter sensor coupled with an Arduino microcontroller that was placed inside of a waterproof container and then weighted down with some type of weight, and then we had pieces of string to kind of control where we wanted to put it at the bottom of the lake. And then how we went about doing this, I did 2 trials. So I placed the sensor, the whole system here at the bottom of the lake at measured depths from 1 to 10 feet. That's about as high, or that's about as deep as I could comfortably control where I had the sensor. And then I obtained light intensity data for 1 minute at the surface of the water, and then 1 minute at the specified depth. So the data kind of the sensor kind of output data in watts per centimeter squared readings about once or twice every second. So I had a big, huge Excel spreadsheet of a bunch of data values. So I went about taking the mean and standard deviation, all that good stuff, of the values out of the water for each trial and the values that were in the water for each trial. And then to kind of represent the data in an easy to understand way, we just took the mean at the depth divided by the mean at the surface to give kind of a percentage of the incident light, or the light at the surface, that reached the specified depth. So these are the results from both trials here. As you can see, the percentages are pretty close to 1 all the way through, and then we kind of had huge outliers here, and I actually took out the data from 9 feet of depth and the data from 10 feet of depth at trials 1 and 2 respectively, just because they threw off the graph so much. We'll talk about that here in the next one. So I kind of discovered that the data is inconclusive, that light intensity consistently decreases at depth as depth increases. If this were true, then the line of the graph would be consistently negative slope, meaning that the values got lower and lower, less and less than the number 1. So, like I said, 1 depth in each of the trials had extreme values, and it threw off the data. And so I think there may have been too much variance in cloud cover or the setting of the sun. It just kind of threw off the readings for that minute that it was underwater. And future study could be to use this light intensity study to investigate the effects of underwater light on algal growth at Clinton Lake. And then I just want to give special thanks to Dr. Heppert and Brad Williamson for their guidance in the study, and my friends Patrick Eastlake and Taylor Lee and their assistance with the procedures of the study. Thank you.